Hello everyone, welcome to DTech. In this video, we're going to look into Agentic AI, what is Agentic AI and its implementation by using Phidata with OpenAI and Llama 3.2 local model. First, we'll try to understand the generative AI and how we're actually using generative AI, and then how come what are the limitations with generative AI, and that is can be solved with Agentic AI. This is an article that I was created on Agentic AI implementation using Phidata with OpenAI and Llama 3.2. First, we'll start with generative AI applications like ChatGPT or Google Gemini. So how we're actually going to use is like maybe we're giving some sort of a paragraph to summarize it. Maybe we'll give some topic to generate some sort of story out of it. So, and also we'll be using some sort of different prompt engineering techniques to get the max out of from the LLM, right? So that is where we actually use generative AI. But the limitations with generative AI is something like if you want to explore on more complex tasks, probably we'll try to explain with an example. So for suppose consider in a product development environment and we are developing a login screen, and what are the usual and kind of a process that we follow is the first step is business analyst will understand the requirement and they will document the requirement, and then they will upload the requirement to Jira, and then developers will come and they will analyze the requirement, and then it is a front end development and then back end development, and then the front end developers they will take they understand the requirement and then they'll create the front end screens for that, and the backend developer they create API calls and then connect it to the databases, and then they create the tables, and then they will validate their unit test. They will be performing their unit testing as well, and finally it will land into QA bucket basically. So where testers will write test cases, test conditions, and then they will actually automate the test cases and then execute the test automation, and then they will find bugs if there are any, and then they will report the bugs, and then the cyclic process will go on, right? So if you see here, it is like it's a process needs to be followed, and then it's a kind of a complex process we need to, because these teams needs to interact daily to actually understand the problems and issue defect fixes and all of that, right? This particular implementation with generative AI will be very difficult, right? So this is where exactly Agentic AI comes in, and then it will help us to create agents to solve the complex problems. And in terms of Agentic AI, we're not actually changing any LLMs here. It takes the complete advantage of the LLM, but at the same time, instead of LLM focusing on generic or general way, it will focus on one particular task at the time, so that it can actually give the better results than generative AI. So that is where exactly the difference between generative AI and Agentic AI. So consider the same example that we actually given here, the product development process with the login screen example. So we have business analyst here. In Agentic AI, we will create an agent, and then the agent will actually create user story and upload it to the Jira, right? So in Agentic AI, there are two things that is very, very common. If you look into any frameworks in Agentic AI, the first one is agents. Agents are really the persons who's going to do that particular work. The second one is task. So what is the task that agent going to work on? Suppose consider here business analyst is an agent, and the task that they're gonna work on is creating a user story, understand the requirement and create a user story and upload it into the Jira. The next concept is tools. Like in order to actually accomplish that particular task, agents gonna use tools. Like suppose in order to create the user story, and then business analyst will be uploading the story into Jira. Jira is a tool here, right? Similarly, developers also, if they want to create any code, or maybe if they have any questions, they will refer to the Stack Overflow or any other tools. Those are kind of tools, or maybe they will actually search that particular exceptions and all. Those all are called tools for that matter, right? So by using agents, tasks and tools, what we're going to achieve is we can achieve the entire Agentic AI flow, and then that particular agent will focus on only that particular task. They're not going to work on any other task for that. Suppose here we have business analyst, they will only work on creating user story and uploading it to the Jira. So here Agentic AI takes the complete advantage of LLMs and focus on only one particular task at the moment, and then These all our agents will be like collaborating each other to accomplish a complex task. That's where exactly agentic AI will help us to build this particular workflow and then understand the complex process and build the complex process as well. So the next step is the agentic AI can be supported by different frameworks such as CrewAI, AutoGen, Phidata, and also LangChain, LangGraph, and all these frameworks will support the agentic AI implementation. But for this particular video, we're actually going to look into Phidata, and then by using Phidata and Local LLaMA model and then OpenAI GPT-4 model, we're going to build the agentic AI workflow, and then we'll implement 4 different use cases for that. So in this video, we're especially going to look into 4 different use cases. The first use case here is we are creating an agent with web search capabilities using DuckDuckGo search. And the second use case, we actually focus on finance agent for retrieving stock information. Basically, if you go to any stock, they will get analyst information, and then P by E ratios and all of that. We're going to get that information by using our finance agent. The third one is we'll develop an agent to get the latest news about the country by using an image. Basically, it's an image search. So I will give a kind of an image of Opera House in Sydney. It will the LLM is will identify Opera House is in Australia, and then it will get the latest news about Australia in that use case. Finally, we are going to look into establishing multi-agent orchestration. So far in these 3 use cases, we're going to look into one agent and then interacting with tools. But in the last use case, we will actually build a team where agents can actually communicate to each other and then get the outcome for that. We'll go complete hands-on in this video, and we'll try to implement all the 4 use cases that we have discussed so far. For that, we'll start with our project setup first. For that, let me create a folder. And I will import the folder in Visual Studio Code. Yep, the first step is we'll create a virtual environment. For that, view terminal, let's create a virtual environment. Python -m vnv.vnv. Once we create a virtual environment, we will install, we'll activate the environment, and then we'll create a requirements.txt file, which consists of all the necessary libraries. So meanwhile, let's create a requirements.txt file here and add all the necessary libraries. We will be using Phidata. And the next one is OpenAI. We'll be using OpenAI GPT-4 model. And then we will be using DuckDuckGo for our search. And then we will be using Y-Finance, which is used for our second use case. And we'll be using LLaMA, which is for our local Llama 3.2 model. This actually created a virtual environment. We'll activate the environment. For that, it's open.vnv. Scripts activate. Now the environment is activated. Now we'll install the requirements. So -r requirements.txt. Now all the necessary libraries are installed. The next step is we need to set up OpenAI API key. For that, go to portal.openai.com and create a new secret key. So I already created one key. I'll be using this key for this demo. And after this, I'll be deleting this key as well. So with that, let's start. And then once we actually created our OpenAI API key, for that, first we'll create a .environment variable. So an environment, and then we'll create a .environment file, and then we'll create OpenAI API key equals to, and keep your key here. And the next step, we will be creating a first basically web search agent .py. So in our first use case, basically we create an agent with the web search capabilities. It will use the tool called DuckDuckGo, and then we'll be using OpenAI GPT-4o model as well. So first we'll actually create a web search agent to actually go and get the information about Nvidia CES 2025 event, which has happened around January 7th, and then we will ask to get all the information, and we'll be using OpenAI GPT-4o model to actually summarize the context for us. So that is what we're going to build as part of our first use case. Start with importing from, as I mentioned, we'll be using Phidata for that. So first we'll start with phi.agent, and we're going to import agent. It will be capital agent. The next step is we'll implement phi.model. We're going to take OpenAI model here, and then import. We're going to use OpenAI chat functionality. And the third one is we're going to use DuckDuckGo tool. So from tools, phi.tools dot, we're going to use, we can see a couple of tools here. We have Airflow, AWS Lambda, calculated. There are a lot of different tools. From the list, we are actually going to use DuckDuckGo, and we're going to import DuckDuckGo here. The last one is we're going to import our OpenAI key. So for that, we'll be importing .environment and import load.environment, and then we will call the load.environment so that we can get the key loaded into this Python file. So the first step is imported all the necessary libraries that we did, and then first step is we're creating an agent here. So create web search agent using DuckDuckGo. So yeah, so and then what it will do basically, get the summary of Nvidia CES event 2025. Right, this is what it's gonna do. So I'll store the results into a agent called web search agent, or web agent equals to. So we create an agent. So we'll send the model. So the first one is model parameter. We'll set the model to OpenAI chat, and then we're going to use ID equals to GPT-4o model. If you have any other models, you need to just mention that the name of the model, GPT-4 Turbo or anything. So we can use the model name here. The next step is we define the model, and we're going to use tool here. The tool that we're going to use here is DuckDuckGo. So this is tools equals to DuckDuckGo, and we'll set some of the instructions here. Instructions equals to, you can actually mention like, please include sources that you are referencing, so that we will come to know from where it is getting the information. And then we'll actually include one more thing called show tool calls, so that it will actually display what are the tools it is calling in behind. So, and also markdown equals to true, so that we can see the output. That's pretty much. We're gonna create an agent, and then we created tools, and then we are giving a model to use GPT-4o model to actually get the results. Here we're gonna use web agent. We'll call this third web agent dot print response. So we ask the query here equals to, can you summarize the Nvidia CES event 2025 key highlights, and I will give string equals to true. That's it, and then we'll run this Python file. So basically we created an agent, and then we are actually asking to summarize the Nvidia CES event 2025 key highlights. So what it's gonna do is actually DuckDuckGo get the information, and by using it gets the entire content, and then by using GPT-4 model, it will summarize the content for us. Let's give it a try how it goes. Let's go Python space search underscore agent dot py. Yeah, I think I didn't give my OpenAI API key. Let me copy it and give it the OpenAI API key. Now I provided my OpenAI API key. Let's give it a try. Yep. Now we can see here it is actually calling DuckDuckGo search. The Nvidia CES 2025 event led by Siva Jensen Hung, and showcase several key advancements, and you can see here RTX 50 series and AI innovations. These are the kind of, and also it is mentioned about the sources where it actually get the data from. Yeah, that's pretty much about the first use case. First use case basically, creating an agent with web search capabilities using DuckDuckGo and using OpenAI GPT-4 model to summarize the context for us. So you can see pretty much this is a pretty simple straightforward steps. We create an agent, we create a model by using GPT-4, and then tools that we're going to use DuckDuckGo. Instructions, we mentioned that a couple of instructions like please include sources that you are referencing, so that we can come to know about the sources that it is referencing. Instruction, that is part of instructions, and then show two calls equals to true, so that we can actually see in the output so what are the different tools it is actually calling behind the scenes. And then markdown equals to true, so that it will display the content in the markdown format. For our second use case, we will actually create a finance agent for retrieving stock related information by using Local Llama 3.2. Basically, like we use Finance tool to obtain the stock related information, and also we can get stock price analyst insights for one of the stock. That's what we're gonna build as part of the second use case. For that, let's see. Yep, we have installed Finance already. So we'll create a new Python file for the finance agent dot py. Same steps like from Phidata dot same, we'll import the agent here, dot agent, and import agent from dot model dot. Remember, last time we used OpenAI, now we will use LLaMA, and we'll import LLaMA, and from, again, this is tools dot tools dot, this time we're gonna use Finance. So Finance tool, import Finance tools. Okay, and the next one is we're going to create an agent for that. So creating an agent, again same steps, whatever we have actually follows. This time we'll create a finance agent, so just finance underscore agent equals to same steps, agent. First we will use model. This time we're going to use LLaMA model, LLaMA, and then the model ID equals to Llama 3.2. For that we have to install local llama here. So for that, maybe if you're not already downloaded, please download LLaMA. Once you download the LLaMA, we can see here LLaMA, and once we actually install LLaMA from here, you can actually go to command prompt, and we can see here LLaMA. It's a recognized command here, and then we can actually LLaMA run, and then we can use Llama 3.2 for suppose, yeah, LLaMA run Llama 3.2. So Llama 3.2, it will download that model. It is around 2 GB. So once you download that, we are good to go. Right, so once we downloaded the model, the next step is pretty much same steps. The next step we're gonna use is our tools. Last time we used DuckDuckGo, now we're gonna use Finance tools. So Y Finance tools. And then there are a lot of methods available in Y Finance tools. If we click on here, you can see you can get stock price, company information, stock fundamentals, income statements, key financial ratios, and list recommendations. So pretty much it sets to false by default. Only stock price is coming. So if you want to get all this information, entire information, you can enable all so that you can set to true, so that we can get entire information. If you want to only get some sort of stock price only, company info and stock fundamentals, we will actually need to mention one by one. So the first one here, we want to get stock price, so we use stock price. By default it is true anyway. And we want something about company info. If we set the company info equals to true, and if you want something like key financial ratios, I will also get key financial ratios equals to true. So, and also we'll set analyst recommendations equals to true, so that we can get the analyst recommendations as well. That's pretty much like we can if you want everything, we can get set. There is a command enable all, so we can set to true so that it will actually get everything for us. The next step, we actually giving instructions to the tool. So instructions, maybe you can actually tell that please provide all the references, or maybe you can say that can you use tables to display the data, so that it will display the data in table format most likely. And show tools calls, show tool calls equals to true, so that we can see what are the calls it is making to the tools. And then markdown equals to true, so that we can actually get it printed in markdown format. And finally, we created a finance agent here. We're gonna call the finance agent dot print response, and we're gonna use, can you give stock details about called Tesla, and stream equals to true. And we'll run our finance agent here, Python finance agent dot py. About LLaMA, I can see here. It will take some time because Llama 3.2 is a local model as well, and sometimes the response is may not accurate as well, because it's a local version and then it is a very small LLM as well. That's the reason sometimes the responses may not accurate. Now it's completed, it's successfully executed. We can see here the output. We can see here is the stock details for Tesla in a table format. It's really good. Name, Tesla, symbol, it's giving all the company information for the matter, and financials, market cap value, total cash value, free cash flow, then operating cash flow, and all of that. And it also gets that analyst recommendations agent. So this is pretty much about our second use case, where we actually imported all the necessary packages, agent, LLaMA, Y Finance, and then we have 5 different things. One is model. We set the model LLaMA and ID equals to Llama 3.2. Tools, we're going to use Y Finance tools here, and then set a couple of options to true. And then these 3 are instructions, we want to display this information in table format, or any other instruction that you have, you can mention that in the instruction section. And last 2 are options for a debugging, what are the tools that it is calling, and markdown, so that it will display in markdown format. So that's pretty much about our second use case. From here it's very straightforward. The third use case that we're going to use here is we're developing an agent to get latest news about the country by using an image. Basically, I'm going to use this image, which is Sydney Opera House. What it will do, basically, will send this information, send this image to GPT-4 model, and then it will it actually tells from which country it is coming from, and then it will give a latest news about that particular country. That's what we're going to implement in our third use case. For that, let's go and create one more Python file. This time it's basically image search agent.py. So this time I will copy paste the all necessary libraries so that we need not to repeat the same thing. Same here, like another first use case web search agent, which we're gonna use GPT-4 model. Here also we're using GPT-4 model, so it's pretty much the same imports, and we'll load the environment, and then we are actually creating a agent image search agent. Model equals to OpenAI chat, and then we're going to use GPT-4 model, and then tools we are going to use DuckDuckGo, and then we create an agent, image search agent, which is going to be pretty much same thing. Can you give information about the image and give me the latest news about the country? So it's basically going to search particular image. It is from Australia, and it will give latest news about Australia. Let's see how it goes. For that, let's go and run this one, Python image underscore search underscore agent dot py. You can see here it is generating very good response. The image shows the Sydney Opera House, which is correct, an iconic architectural landmark in Sydney, Australia. It is recognized for its distinctive shell-like and of that, and then it is giving the latest news updates about Australia. Right, this is really good. Planet parade view, there are a couple of updates, and also it gives some sort of links as well, so that we can actually refer the source that is actually referring from. It's pretty good. This is our third use case. Basically, we are giving an image, and then it is searching that image, and then it is actually identifying which country it is coming from, and it is giving latest news about that particular country, which is really good. And also we can see it's pretty much same options that we used in our web search agent as well. Last one, which is our establishing our multi-agent orchestration. So far we actually using one agent, one tool, and then performing some actions on it. This particular use case, we're gonna build multi-agents. All agents work together as a team to get the results for us, right? For this particular use case, what we're gonna do is we're gonna build two agents. One is dedicated to find the latest news regarding Tesla, and then the other will actually retrieve the stock price. Basically, we are actually combining the first two use cases into the fourth use case, and then we're gonna build a team that these two agents work together as a team and get the results for us. Right, for that, let's create a Python file. It is multi-agent. Agent orchestration.py. I'll do the same because we're going to import the same thing. So I will copy paste the code, and because it is pretty much same thing that what we did in our first use case, which is creating a web agent. Here we can see web agent model tools show tool calls equals to true, and instructions, please include the links that you referenced so that it will get the links for us as well. This is the first agent, and the second agent that we're going to create is finance agent. This is the second agent that it will use by finance tools to get the stock related information, like we just mentioned stock price, analyst recommendation is true. We can set all other options as well, but for this particular use case we just limit to two of them. That should be fine. Now the third step here, because so far we followed and then we actually created agents here, pretty much same steps. The next step is we're going to create a team, that in that team we'll add these two agents, and it will work together, and then it will generate response for us, right? For that, let's create a team. For that, it is agent team. Go for fancy. We'll create an agent here. We'll create team here. So team team has two agents here. First one is web agent, second one is finance agent, and we're gonna use model here. Same steps, just the only the difference here is how we're creating agent and how we're actually creating a team. We're going to create a team here and then add the respective agents here, and after that, it's pretty much same steps, like what are the model that we're going to use. It's pretty much OpenAI chat, and then ID equals to GPT 4o. Instructions, we can mention that please include the references, and also you can mention a couple of instructions by saying one more thing: display the results in table format. Okay, and then same options: show tool calls equals to true, and finally we have markdown equals to true. It's pretty much. And how we gonna initiate agent team is agent team, same thing, print response. So this time we're gonna give maybe we'll give Nvidia this time. Summarize analyst recommendations and get latest news about Nvidia. We'll mention stream equals true. All right, that's it. We created our first multi-agent orchestration here. We created two agents, pretty much same steps, and then we created a team so that these two agents work together as a team and generate the response for us. So to run this one, Python space agent underscore orchestration. You can see here running transfer task to agent 1, agent 0. Agent 1, it distributed the tasks. Agent 1 retrieve latest analyst recommendations for Nvidia Corporation, and the agent 0, which is doing first agent, is doing search for the latest news about Nvidia Corporation. So they're two different tasks. One is searching for the latest news, another one is for latest analyst recommendations for Nvidia Corporation. You can see pretty much, you can see here yeah, it's generating the response. We can see here this is the period, and then currently it is 12 strong buy, 46 buy, it is really good, hold is 5, which is really strong recommendation of buying this particular stock, and then last 1 month, 2 months, 3 months ago, it's a strong buy, so it's a highly recommended stock as well. And the summary, it provides a very good summary about the buy recommendation is slightly decreasing with a small increase of hold ratings, and then these are the couple of articles it referred to generate this response. This is really good. And also it gets the latest news. This is the summary of the latest news, January 12th 2025 10th. This provides the summary of these articles, and at the same time it provided the reference links as well. So this is really good, did pretty well. These are the 4 different use cases that we actually implemented by using Phidata and OpenAI and Llama 3.2 models. We used both open source as well as OpenAI model as well. It's pretty much about our 4 different use cases we implemented by using Agentic AI. And then the entire source code is in our GitHub here. And also I'll provide the link, this Agentic AI, you can see pretty much in this GitHub, the source code mentioned here. And the article for this particular one, I keep it in my description section. So if you want, you can refer that article as well. It's pretty much. Thank you everyone. See you in the next.